Stay away from this supernova. It could swallow the Earth in seconds if it were nearby. Sure, it would be nice if we knew exactly when a large star was going to die and go supernova. A team of astronomers has indeed used this approach. If you see a huge red star surrounded by a thick cloud, be careful, since it will likely explode over the next several years. A massive star goes through many violent phases as its life cycle winds down. And there is one with trillions of tons of force that you can see every night with the naked eye that could start the most massive explosion in our universe. Let's find out why some scientists call it the new Big Bang. The core. A star's core is where it transitions from fusing hydrogen to fusing helium and eventually heavier elements like carbon, oxygen, magnesium, and silicon. The last stage is iron formation inside the star's core. Iron's detrimental influence on energy means that the star will die within minutes, and its spectacular self-destruction, known as a supernova, will be seen across the universe. Yet, despite the disorder among the stars, it is hard to make sense of what's going on within. The massive size of these stars is a sure sign that their lives are shortening. Potentially hundreds of times brighter than the sun's glare, the swollen surface of these stars make them seem to be red giants, while their actual outer temperatures are dropping. With a mass of more than 16 times that of our sun and a diameter of 764 times that of the sun, Betelgeuse is so enormous that it could swallow the orbits of every planet in the solar system except for Mars if it were placed at the center of the solar system. That's the equivalent of a diameter of 600 million miles, or nearly 700 times the size of the sun. Its surface temperature is just 6,000 degrees Fahrenheit, which is rather cool for a star. Because of the low temperature, the star's hue will be shifted to an orange-red. Betelgeuse is over 7,500 times more powerful than the sun in terms of the amount of energy it releases. The most well-known example of a star in this group is Betelgeuse, and Betelgeuse is very near the end of its life. If this star, which is only 11 times as massive as the sun, were placed in our solar system, its radius would reach Jupiter's orbit, and Jupiter is 365 million miles away from the Earth. It's hard to wrap our heads around such a massive size. It will soon go supernova, but in astronomical terms, any day may mean a million years from now. A more precise prediction cannot be made than the commonly known fact that all stars of this kind will eventually explode in a supernova. It is a ticking nuclear bomb. Nuclear space bombs. In recent years, astronomers have discovered a process that allows them to accurately forecast which supernova will burst within the next few years. Only a few dozen Type 2P supernovae were studied in detail because of their peculiar characteristics. However, the light from these explosions may continue to shine for a long period after the first burst, making them unique among them. Red supergiants like Betelgeuse have been the targets of this re-examination since scientists have found photographs of these stars taken just before they explode after being rediscovered in old catalogs. That's undeniable proof that stars like that may trigger supernova explosions. Theoretically, these explosions occur in stars with thick envelopes of material. The veils around Betelgeuse are extraordinarily thick compared to the surrounding space. There's just enough debris lying around to keep things burning long after the early signs of the explosion have faded away, thanks to the shockwave's initial heating. These supernova, which are hidden by a dense shroud, are formed far earlier than their less cloaked counterparts. As the first shockwave from the explosion passes through the material around the star, it gradually loses energy. High-energy radiation like X-rays and gamma rays can be produced by supernova's initial energies. Once the shockwave and the surrounding material have mixed, however, the emitted radiation is in the optical spectrum. The presence of these enormous envelopes of material around stars is a warning sign of an imminent supernova. If you were to make a veil, how long would it take you? The researchers looked at two distinct models in their inquiry. Parts of the star were disconnected and scattered over the course of decades, creating the shroud, according to one explanation. In the second scenario, which portrays the star's catastrophic pre-supernova explosion. Gas equivalent to up to 1/10 the mass of the Sun was expelled from the star into orbit in less than a year. The group next utilized computer simulations to figure out how the dust and grime would affect our sight of the star. As soon as the star erected its cloak, it would be almost impossible to detect with the current imaging technology. Since direct photos of some of the pre-supernova stars were acquired less than 10 years before they went off, the researchers concluded that the slow and steady notion wouldn't work. The star would have been obscured otherwise. A supergiant star will likely go supernova within a few years once it forms a thick envelope around itself. You've been warned in advance should you find yourself in this scenario while traveling through space. Astronomers have created an early warning system to sound an alert before a massive star bursts into a supernova. Recent research has demonstrated that big stars, usually between 8 and 20 solar masses in their last phase of life, the so-called red supergiant phase, abruptly become roughly 100 times fainter in visible light in the final few months before they die. This dimming is due to a sudden accumulation of dust and gas in the star's vicinity. Supergiants. Red supergiants are supergiant stars with a spectral type of K or M. They're the biggest stars out there. Despite their size and brightness, they are hardly the most impressive objects in the universe. Betelgeuse and Antares are the two brightest and best-known red supergiants. How long it took for the star to accrete its mass remained a mystery. Since that erupted roughly a year after being captured by telescopes, provide proof that such photos exist. In these images, the stars do not seem to have formed the expected cocoon around themselves. This suggests that the cocoon can be built in much less than a year. The heavy garbage practically entirely obscures the star, making it 100 times less luminous in the visible spectrum. To see a star a day before it bursts, it must be very bright. Another thing is that we've only been able to catch complete photos of supernova hours after the explosion. The most advanced telescopes in the world can be pointed in the direction of the precursors to the explosion if we know which stars to keep an eye on. It appears that Betelgeuse is undergoing a massive ejection event, in which material from its outer layer is being blasted from its innards, possibly beginning as far as 1 billion kilometers from the core. However, this is not conclusive evidence that Betelgeuse is about to go supernova, and there are other possible explanations for its brightness. Although the likelihood of an impending Betelgeuse explosion is low, it is nonetheless good to be prepared for the potential. If it is visible for a year or longer and occurs when there are more people on Earth than ever, it will undoubtedly break all records for the most watched celestial event in human history. This might happen tomorrow or 100,000 years from now. Betelgeuse is an unusual object to see, but the fluctuations in its brightness are caused by motion in its outer layers and have nothing to do with the star's true makeup. Betelgeuse's supernova explosion is theoretically feasible at any moment, but it cannot explain the current fading. Many other stars, such as Deneb and Rigel, are brighter and hotter than Betelgeuse. Blue supergiants are the most massive stars known. The brightest stars, including the Sun, aren't always the warmest ones. Our planet would lose its atmosphere and all life on it if a supernova explosion occurred within around 25 light-years of Earth. However, astronomers have not discovered any potentially dangerous supernova candidates in our cosmic backyard. Which is your favorite star in the sky? Tell us in the comments, leave us a like, and subscribe for more videos like this.